All right. Woohoo. Okay, Liz. It's just you and me. I'm gonna get our book open just in case. Yeah, I don't know where Sam is, but I didn't get an email from him. That's what I was wondering. Okay, so question 3. Despite the margin of error for a 90% confidence interval, when the standard deviation is 50 and n equals 25. Lucy, do you know what the
So yeah, I use
equation?
a margin of errors formula to solve that problem.
Yeah, what's the formula that you
So
use?
the z-scores times the standard deviation divided by the number of population squared, or
So that's
square
the
root.
margin of error.
Yeah. So I came up with a 16.45.
I'm just looking through this really quick again. Okay, I think you're right then, because I think this is the z-score. Okay. So you found the z-score of
So,
the
so
90% first?
if you go a little bit underneath, they will give you the table for z-scores in the textbook for
Yeah,
the 80% and 95%.
even down.
Yeah, the,
Oh, right there.
yeah,
Yeah, I found it right here too. You can. I just put it into the probability applet.
yep.
I don't like having to memorize. Yes. So we'll use the z-score and then we'll times it by the standard deviation, right? Which is like standard deviation divided by the square root of n.
Yeah.
Cool. Probably right then, because you probably did the calculations right. And well, that's so easy. So you got this. You see what I got?
Yeah.
16.45.
Yep.
And that seems right to me. Oh, these questions are so hard. I was too confused. Rachel's back on at least. Oh, I see where that full equation is. you know which one it is? I don't know. I always get confused with like point estimator. Thinking it might be um,
I was thinking that X is a point of estimate of the uh, population mean.
sorry, you cut out. What was that?
Like the sample mean is a point of estimation of the population mean. So that will be the second.
Yeah, yeah. This one right here, x bar is the point estimator for mu. Or do you think it's the other way around?
No, because I think because the population mean are given. I mean the sample mean are given, and we are trying to guess or tell where the population mean might be, because the population mean is unknown.
That's true. That's true. It's kind of like it's trying to say this one should be near this other one.
Yeah.
But wouldn't that mean that the mu one is a point estimator for x line with the line x bar? I don't understand which one's going which way.
Uh,
May I offer some a tip?
Yes.
So typically we are always, and in fact, I've never seen an instance where this is not the case yet. But typically when we have a Greek letter, like we have that Greek letter mu, that's for the population. And when we have a regular letter like the X there, which is it's actually X bar, we're talking about a statistic. So in this case, X bar is a sample mean, which is a statistic, and mu is a population mean. And the purpose of a statistic is to try to estimate a population parameter.
Oh,
Does that make sense?
yeah. So we're having. So I think it would be this one because it'd be x bar would be estimating where the real population mean would be.
Exactly.
I gotcha. I gotcha. So it's got to be this one. I think
Cool.
it'd be that one. I don't understand these other two, but
Yeah, I think they're just distractors because the standard that's talking about the standard deviation, and the standard deviation is
Yeah.
it can't be. And actually, the standard deviation squared. I don't know if you guys have gone over this yet, but the standard deviation squared is the variance.
Oh,
Have you talked about that yet in your lesson? I don't
yeah.
remember.
We had some variance. We had some
Okay.
variance for the last one.
Okay. Yeah. So those are just distractors.
Okay, good to know. Alrighty. Do you know if Rachel's alive yet? She's still. Oh, she got up again. She's probably having a hard time. Still. Alright, let's keep going then. Okay. So this next question is asking for a 95% confidence interval, which is 2 standard deviations, if I remember correctly. Pretty sure.
Mm-hmm.
Yeah. Then she knows the standard deviation, collects random sample, and computes this. What is the point estimate for the true GMAT score? Wait, isn't X bar the point estimator? Didn't we just learn that?
So that will be the value of the X, right?
Yeah, that's what I was thinking too. Because we just learned that X bar is a point estimator. So
Yep.
then it asks what the margin of error is. Oh, this is a 95% confidence interval. Is the margin of error the same as the confidence interval? I don't think so. But we'll see.
Sorry, was that directed at me?
Oh, I was just asking Lucy. I was just asking a general question.
Oh,
Well, we can do this. With our Rachel, are you back? Rachel is still broken.
Yeah. So we'll use just a margin of error formula, isn't it, to solve this problem?
Well, I think so, but I wasn't sure. Adam, you might know this. Is a 95% confidence interval the same as the margin of error?
so they are related, but they're not the same thing. So a confidence interval is going to be, you're going to have two numbers for a confidence interval. And
Gotcha.
in fact, let me see if I can find it in the textbook.
There's one right here that talks about finding.
Here we go. I'll oh yeah, you've got it right there. So
Yeah.
if you notice, the formula for the confidence interval is the point estimate plus or minus the margin of error. So you need the margin of error to calculate the confidence interval.
Yeah.
So they're. Go ahead. Sorry.
Oh, I was going
I was
to more on the top. You'll find a formula for the margin of error.
Yeah.
Oh, okay. So this says it's a 95% confidence interval. And then it shows that these are the two values, and so I'm guessing you still use it as like this is the z-score that you're going to use.
If you read on in the textbook, it explains this, but it's getting that z-score from the empirical rule, the 68%, 95%, and 99.7% rule. Yeah, as it explains right there. So that's an estimate of the true z-score, basically. So when you actually do the calculations, you'll want to use the actual z-score, not the estimated z-score. And the actual z-score is, you can get it from the probability applet.
So you use this?
Yep. Yeah, you would use the 1.96.
I gotcha. That's why down here it tells you that 95% confidence level is 1.96. I was wondering. That makes sense. Okay, yeah, I think we're just going to use the equation, but we're going to use this z-score from the 95% confidence thing. So we can. Sorry. So
Sorry, did you have a question for me? It kind of cut out a little bit.
No, I think we're good now. I think we figured out what we need to do for this one.
Okay.
So we need to do. Oh, for a second. I have to do these problems backwards because my calculator doesn't like this.
How do you get a scientific calculator for a computer?
The scientific one?
Yeah.
So I have Windows 10, and when you open your calculator, you'll just click on these three lines right here. It'll be set to standard normally. And if you just go to scientific, you can change it to have like parentheses and stuff like that.
But it doesn't have the lines that.
But if you have like Windows 8 or something, it'll actually pop it up in like an application that goes on your whole screen.
Okay.
And on that one, you have to like, Emily, on your calculator, where's the button that you push to change it to scientific? At the top right here. Okay, and then right at the top, like when it's in the big window, it's just going to have a choice. It'll just say scientific. It's right above the whole calculator. Do you have Windows?
No.
Oh, do you have like Mac or something?
Yeah, I'm with Mac.
Yeah, I have no idea how Macs work.
That's fine. I'm using the Excel instead because Excel works better for me.
Oh yeah, that's cool. So this is what I got. It doesn't say it around to 3 decimals, but I hope it's right. Did you get this, Louis? Do you see what I got?
Yeah.
27.685.
Yeah, that's correct. Yeah, that's what I get too.
Okay, cool. Then I asked for what the lower limit of this confidence interval is. What's the lower limit?
So then we'll just subtract that one from the 526, isn't it?
Right, so we do the number minus this margin of error.
Yep.
526 minus this number. And we get 498, 315, and then the upper level is adding that, right? Are you sure?
Yeah.
That is not what I wanted. Sorry, I was getting distracted. Okay, so I think we got those right. 553.685, and then the first one was 498.315.
Yep.
Cool. So what would happen to the width of the confidence interval if Gina increased the sample size? Oh. So our confidence interval. Wait, I thought the confidence interval was just like what she already decides on.
So how far the data is extended? how far it goes?
It's asking what's going to happen to the width of the confidence interval if she increased her sample size. I just got a message. 1 second. From Rachel. Question 6, I had 27.685. Cool. Looks like we're doing good then.
Sweet.
I'm going to tell her that if she can get on, she can type to us.
Yeah.
So if she increases the sample size, her data should get closer and closer to the population mean. What does that do for the confidence interval? Shouldn't her confidence interval go up then? Like,
One thing that I really like it is when I get stuck is like I plug in and like a sample in the formula,
wait,
and then I know if it increases or decreases. That's what helped me to
oh
realize.
yeah. Sample sizes are. Yeah, I don't think her confidence interval should change at all though because she's just confident. Like she's just 95% confident that the true one lies within it. I don't feel like it should, but maybe it does. Oh, here's a good helper. Pretty much says the same thing. This says that if the sample size is increased, the width of the confidence interval will.
With what?
In this question right here, it like explains it. So it's saying your n is the denominator, and the fraction is going to decrease when this it's going to make it smaller, a smaller margin of error, which is going to make your confidence interval decrease because you have less of an area that your true mean could be with. And that makes sense because as you get a smaller margin of error and you get more people, this z-score is just going to get closer and closer because this is going to be the probability that you have the actual population mean. If you get enough people, you could have like a 18% confidence interval where you're like, it's got to be within these two numbers.
Now for some more advice.
Yeah.
Does it make sense why the confidence interval would decrease as your sample size increased?
Forget. I was just reading what Rachel said.
Sorry, the mic is cutting out quite a bit. I didn't catch that.
Oh, you're good. Sorry, my mic usually cuts out because I have to use two different computers and my laptop is really bad.
Oh, no worries.
So I only use my laptop for my mic.
So with the confidence interval as your so your 90 this is true of any confidence interval, 99%, 95%, 90%. If you have a larger sample size, then you have more power to you have greater power to estimate the population. So your confidence interval will get narrower. So a narrow confidence interval theoretically is better. Because what you're saying is we are 95% confident that the true mean lies lies between these two numbers. So the narrower that those numbers, well, not necessarily the more confident we are, because we're still 95% confident, but the scope of the range of the numbers is narrower. Does that make sense?
Yeah. That's what I was saying. I was trying to explain it where it's like, well, I was reading it in the book right here, but it said that you have a greater chance of having your population mean within the two numbers that you found. So it's like, even though you're still 95% confident, you're confident that it's with a smaller setup.
And with the normal probability applet, and this is the part that's kind of tricky. The two numbers that make up your confidence interval, they still correspond to the second standard deviation, or the z-score of 1.96. So it's just the numbers that correspond to those z-scores gets narrower, but your z-scores don't.
Gotcha. So it's still the same. So this is still like a 95% confidence interval, but this z-score would correspond to, instead of like a 27.685, it would just be like a 20 point something.
Yeah. Yep, exactly.
And so this would still be two standard deviations of 95%.
Yep, yeah, exactly.
But what I don't understand then for question 9 and 10 is they're asking what's going to happen to the width of the confidence interval, because we're still 95% confident, aren't we?
Yep, that's correct. Yeah, you're still 95% confident, but the numbers that correspond with that confidence interval get narrower or change depending on what you do.
Yeah. So is that still going to make it so like the width of the confidence interval, is it going to change?
Yeah. Mm-hmm. The width of the confidence interval changes, but not the confidence itself. So the interval is changing, but not the confidence level.
Yeah. And so for question 10, would it increase just because you're putting more numbers into the confidence interval?
Yep. Pretty much. So this is pretty much the opposite. Because if your sample size, I mean, because I'm assuming that this question is saying that the sample size stays the same. If the sample size stays the same, but we increase our level of confidence to 99%, as opposed to 95%, then we have to get a broader range in order to be that much more confident.
That's what I thought. I was like, well, the only way to get to 99% would be to put tons more numbers in there. So.
Yeah.
All right. So I'm pretty sure 9 is decrease and 10 is increase then. Okay. Woo. All right, Lewis, you got everything? You're on question 11 now. You're good.
No, I think I'm good. Hopefully I'm good.
Okay. I'm just opening the chat really quick to make sure that Rachel is here. Let's see what she said. Q10 is increased. Okay. So she agrees with that. Oh, so they're giving us the margin of error in this one. Okay, let's go to these equations. So if for question 11 is asking for x bar, so we need to flip this equation around. I'll just go to the simple one. Okay, so first we need to find, I guess we just need to find an n, right? Times the z-score. Okay. Oh, I don't know how to flip this around. My brain's freaking out at all these divisions and stuff.
So now I think we need to solve for sample sizes.
Yeah. I'm so glad they flipped it around for me. Okay, so this thing says that we're looking at a 95% confidence interval, so we're looking at the same z-score. The book says that we're going to times this. That's right. 2, 4, 5, 8, 6, 3. Wait, nearest whole number. Okay, 2, 4, 6. Okay, Rachel got the same answer too.
Yeah, I did get the same answer too.
So perfect. Then we're all doing it right. I'm just going to type it to her. Okay, so I'm pretty sure we did that right then. Next question. What is the lower limit? Okay. So I'm not 100% sure, but the level of significance is that confidence interval, or do we need to find the z-score from these three numbers? Do you guys know which equations I'm doing right now? You're probably not even watching. You're probably doing your own equations, huh? Okay, so I got a z-score of 1.63354, huge number.
So on this one, it's actually the same. You'll be using the same formula as
Oh,
the
right.
last.
I didn't even see this.
Yeah.
There's a 95% right there, so I don't even need that.
So this is what I didn't understand. So like you said earlier, this is just to distract you set up the hypothesis test with a level of significance of 0.05.
Yeah, so we don't need this one for question 12 at least, or 13, because it's just asking for the upper limit and the lower limit on both of these. And we have the 95% confidence interval, so we just need to find the margin of error first.
Yeah.
So we have to do 36, which equals 6 at the square root, and then do 36,730 divided by 6. I have to put it into my memory. And then we have to times the z-score by that. And I'm pretty sure this is the margin of error. I got 11,998.
Mm-hmm.
But round up to 99. I'm not sure.
We can still do the calculation to the end, and the end we can, because it says round to a whole number.
Oh, right. So we need to minus this from 111. So we're doing the lower limit first. So we'll do 111,000 minus that number. So I got 99,002. For the question 12. Did the same thing.
You want to watch the rounding on that one. It doesn't round up; it rounds down.
It never, even with the sixes right here, the six
Yeah.
will round down.
Because the next,
so it'll still round down.
Yeah, the number right after the 8 is 4.
So it doesn't like on Island, it doesn't care about these last numbers.
Yeah, no.
Okay, that's what I was wondering. I wasn't sure.
I could be wrong, and I do know for a fact that it does round down to an 8, not a 9.
Okay.
And I could be wrong, so don't quote me on this, but I think iLearn will actually accept a range of answers.
Yeah.
So I think both answers iLearn will take it, but I don't know for sure. So just play it safe and round down.
Yeah, that's usually what happens. It happens a lot when they do between two numbers for iLearn, because it's hard for people to get the exact same answer. So Lewis, do these look right to you? And Rachel?
No, I got confused here, and so I didn't get how to solve this problem, because I get confused when it says you set up a hypothesis test with a level of significance of A equals 0.05.
Yeah. So for this question, we don't really need to know that part for question 12 and 13, just because all they're asking for is the lower limit and then the upper limit. And those are the same things that we did up here in question 7. And so it gives us a 95% confidence interval on each of those questions. So we don't need the A equals 0.05.
So yeah, it's kind of like distraction, like Sam was saying. Okay. Yeah, that's what I thought.
We don't need that number right now. They're just trying to confuse you by throwing in all this high-tech stuff.
Yeah. Yeah, so yeah.
Yeah, the purpose of that is to just make sure that you understand what terminology they're using.
Uh-huh.
So, I mean, they give you it typically when you're looking at a problem to calculate, you'll get all of that information in the question. So this is just helping you practice knowing which parts of that information you need to calculate different things. So
Okay.
yeah, just like Eric said, you don't need the level of significance to calculate that.
Yeah. Okay. All right. Thank you.
Yeah. So then the last question says, there are 3 requirements that need to be checked when computing confidence interval for a mean. They are, ooh, well, there's 3 here.
So I think all of them, isn't it?
Yeah, I'm pretty sure you do need all of them because you have to know what the standard deviation is,
Yeah.
and then this has to be normally distributed or it's going to be completely off. And then the simple random sample is X bar, so you need that.
Yeah.
So I'm pretty sure you just need all of them.
Yeah, I think so too. Yeah.
Okay, should we turn it in? So wait, Rachel's asking a question. What did you get for 12 and 13? I'll put these in really quick. I am typing in the wrong computer. Okay, let's see if she agrees with those. I think we got them all now.
I'm trying to recalculate, but for them.
Okay, Rachel said yes. She thinks they sound right.
Yeah.
Liz, you good? Are you good on 12 and 13?
Yeah, and the third thing I got the 4 878.
Wait for question 13?
Yeah.
So on 13,
I mean for
whatever
the
number you minus from
12 and the third. Yeah, for the 12 I got 104,878, and for the 13 I get 117,122.
Okay, so what was your margin of error? What did you end up getting for that?
How did I end up getting that?
Your margin of error. Do you remember how you got that?
Yep. So the margin of error I got 6,121.
Okay, so for the margin of error, we need to go. The first we define the standard deviation, so we do 36,730 divided by the square root of n, and the square root of 36 is 6. So I'll just do that, and then you get this, but then you also have to times that number by the z-score.
Uh-huh.
So you have to take this number and then times it by 1.96 for the 95% confidence interval here.
Mm-hmm.
And then you should get 11,998. Does that make sense?
Yeah. Yeah, it does make sense, yeah.
Yeah, I think you just forgot to do the z-score part.
Mm-hmm. Yep. Yeah.
So then we should end up getting 99,002, and then 122,998.
Yep.
And then we will submit it, see how we did.
Yep. Good. Yeah.
And it looks like we did it. Woo-hoo.
Well done. Yeah, you guys did a really good job. I think the biggest thing was you guys seem to do really good with the equations and figuring out how you need to calculate things. I think the biggest thing to watch out for is just the terminology, which you did all right with that too. But yeah, well done.
Thank you. We got some things figured out. Sorry, it takes a little bit longer to get things going with our groups because sometimes people show up late, like me today, and there's just like problems with all the computers and stuff.
Oh yeah, no worries. Cool. Well,
So
I'll go ahead and sign off unless anybody else has any other questions for me.
do we still need to post this to the discussion board?
Yes. Yeah.
Okay. Cool.
Cool. Any other questions from anybody?
I think I'm okay. Thank
I'm
you.
good.
Okay. Cool. Yeah. Good work. And I will sign off now.
Okay.
All right. See ya.
Bye.
Thank you, Eric.